Math is a wonderful thing. Math is a really cool thing.
Alright, moving on to Unit 5. The first topic that we are going to discuss is direct variation. Direct variation has two variable quantities that have a constant ratio. It has the form y equals k times x. So in this equation, y equals k times x. If we are going to isolate our k, so divide both sides by x, we will end up getting k equals y over x. This k here, which is equal to y divided by x, is what we call constant ratio. It's actually a fancy name for slope. So with this unit, with this topic, whenever we look for constant ratio or slope, we just have to divide your y by x. One of the characteristics of direct variation is that if one variable increases, then the other variable also increases. If x decreases, then y also decreases. Here are some of the examples. So for hourly wages, the more time that an employee will be given a chance to work on a given period of time, the more salary that the employee is going to take home. Now, of course, if you are being paid as hourly wages, the less time that you will be given a chance to work, the fewer salary that you're going to get at the end of the month, for example. Another examples will be when you travel, the gallons of gas used and miles traveled, and for the food recipe, the number of servings and the ingredients. This is the equation for our direct variation, y equals k times x. Or, again, as what we've said earlier, your constant of variation, which is your k, is just the ratio of your y and x. It's very important that your k here is not equal to 0. K is a constant of variation, or again, it's just the slope, and then we say that y varies directly as x. Going back to our slope-intercept form, which is given as y equals mx plus b, our direct variation equation is actually of the form slope-intercept form. The y-intercept is actually equal to 0. It means that whenever you graph a direct variation, the graph always passes through the origin. If I'm going to graph a direct variation, it will just be a straight line passing through the origin. One example will be this straight line. Now this straight line passes through the origin. Another example will be this line. Provided that straight line passes through the origin, it will be a direct variation. Here are more examples of graphs of direct variation. As long as you have a straight line that crosses the origin, it will be a direct variation. Now the following are not graphs of direct variation. While this is not a straight line, so it's not a direct variation. Now although this crosses the origin, it is not a straight line, so not a direct variation. Now we have here a straight line, but it did not cross the origin, so it's not a direct variation. Now this crosses the origin, but since this is not a straight line, this is not a direct variation. Writing an equation for direct variation problems. So let's try to solve problems 1 and 3. So a person's payment P varies directly as the number of hours H worked. Note that our general equation for direct variation is y equals k times x. And our constant of variation or the slope is your y divided by x. Again, we can find our constant of variation or the slope by dividing both sides by x to isolate our k, and then here your k is equal to y over x. So the easiest way to write a direct variation problem is to identify the quantity before and after varies directly. Your varies directly will always be represented by equals k. Now the quantity before this is the person's payment, which is P, and then the quantity after the varies directly is the number of hours represented by H. If we are going to solve for the constant of variation or the slope, we just need to divide both sides by H. So we are just isolating our K. So your K here will be equal to P divided by H. So the equation is P equals K times H, and the constant of variation is P divided by H. Example number 3. The number of pieces P of mail processed by a machine in the post office is directly proportional to the number of minutes M that the machine runs. So in this case, we did not use the varies directly, but we use directly proportional. Okay, they mean the same thing. So that's just equal to K. Now the variable before directly proportional is P, so you will just write P before the equal sign. Now the quantity after directly proportional is the number of minutes, or M. Just write M after the equal sign. So our direct variation equation is number of pieces is directly proportional to the number of minutes. If we are going to solve our constant of variation, we just need to divide by M to both sides, and we will have P divided by M. Okay, so go ahead and pause the video and solve for questions 2 and 4. Alright, next, given a table, how do we know if we have a direct variation? Let's try to find also the constant of variation. So we have here 5 questions. So I'll solve 1 and 3. So we know that a direct variation is y equals kx, and the constant of variation is k equals y divided by x. So what you need to do here is just divide your y by x for each ordered pair. And if we have the same k, then it will be a direct variation. So here, we just need to divide y by x. So 8 divided by 4 is equal to 2, and this will be our k. 14 divided by 7 is also equal to 2. 20 divided by 10 is also equal to 2. Since my constant of variation or the slope are all the same, then we can say that this is a direct variation. What will be the equation? It will be y equals kx, but the k here is equal to 2, so it will be y equals 2x. Alright, for number 3, again, same procedure. We just need to divide y by x. So 3 divided by 0.1 is equal to 30. That's our k. Next, divide y by x. So 0.1 divided by 3 is equal to 0.033, repeating. Now since I have a different k here, we can now conclude that this table is not a direct variation. Alright, go ahead and pause the video and solve for problems 2, 4, and 5. Alright, next, given the graph, let's identify if we have a direct variation or not. Now remember that the graph of a direct variation is a straight line that passes through the origin. So I'm going to solve all odd numbers. So I have a straight line here, but it did not cross the origin. So this is not a direct variation. Alright, I have a line here and it crosses the origin, but it is not a straight line. So this is not a direct variation. Okay, for number 5, I only have a graph on the first quadrant, but this line starts at the origin, so therefore 5 is a direct variation. Yes, this is a direct variation. Number 7, again a straight line and starts on the origin, so 7 is also a direct variation. Alright, go ahead, pause the video and solve questions 2, 4, and 6. Now, let's find the equation given a graph of a direct variation. So if we look at question number 1 or graph number 1, the x-axis is represented by h or hours, and the y-axis is being represented by miles or m. Note that in general, the equation should be y equals kx. Okay, so I will have y, which is m, equals k x. Our x here is hours, so I'm going to use h. The only problem here is that I don't have the k, the constant of variation, but k is just the slope of this line. So if we can just find 2 points, so we can just use this point and this point here, and then let's just find the change in y. So this is 50, 100, so that's 100 over, this one is 0.5, and then 1. So the slope is 100 over 1, or equal to 100. So the equation will be m equals 100 times h. Alright, for question number 2, go ahead and pause the video. Find the equation for this graph of direct variation. Our next problem. So we have here point A, and it says here that point A is an element of a direct variation. Now let's find 2 other points other than A that are also element of the direct variation. So the best way to solve this type of question is by finding the slope of your line that will start here and ends at point A. So what is our slope? So I'll just go up. Okay, that's 1, and then to the right. Alright, so that's 1/2. If we will use the same procedure, we'll go up again and run to the right twice. We'll be able to identify another point that is an element of this direct variation. So this is 4, 2. Let's do it once again. Go up once, run twice to the right. So this point is also an element of this direct variation, which is 6, 3. Now if you want, you can do the opposite. Instead of going up and going to the right, we can also write 1/2 as -1 over -2. So it means that from the origin, I can go down once and then run to the left twice. So this point is also an element of your direct variation. So if you need more than 2 points, another point will be -2, -1. And we can keep doing the same process if we would like to generate more points. So again, go down once, left or run to the left twice. So again, this will be another point that is an element of this direct variation, which is -4, comma, -2. All right, for problem letter B, go ahead. Okay, next, for this problem, I'll just solve again odd numbers. So let's find the equation if y varies directly as x. So from here, I can write the equation y varies directly as x. The equation is not complete because I don't have the value of my k. So to find k, I'm going to use this given y equals 9 if x is equal to 3. So I can just replace my y by 9. X is equal to -3. Solving for k, just divide both sides by -3. We'll get k equals -3. So the complete equation is y equals k. Let's write my y here. Y equals k, but our k is -3, x. So this will be the equation of this problem. Next, a person's payment P varies directly, so this here varies directly as the number of hours worked. For working 8 hours, their pay is $96. So 8 here will be hours, and then the pay is $96. Find the pay if a person worked for 20 hours. So before we can answer this question, we need to set up our equation. So remember, varies directly means equal to k. The variable before this is p, so you have to write p before the equal sign. The variable after varies directly is hours, so write h after the equal to k. Again, our equation is not yet complete. We have to find the constant of variation. It's given that the h is 8 and the pay is $96. So when you divide both sides by 8, 12. So our k is equal to 12. So to complete our equation, I will have p equals 12 times h. Now find the pay. So we're looking for the p if a person worked for 20 hours. So if your h is equal to 20, what is our pay? So we'll just have to replace your h here by 20 using the equation that we derived. So 12 times 20 is equal to $240. Alright, go ahead, pause the video and solve for problems 2 and 4. Alright, next example. So we have here a painting contractor determine the average amount of time needed to paint a house. If we have 3 painters are used, it takes 15 hours to paint the exterior of a house. And if we have 6 painters, it takes 7.5 hours to paint the exterior of a house. Now let P represent the number of painters and H represent the amount of time in hours required to paint the house. So let's state whether this relationship is a direct variation. If it is a direct variation, let's write the equation for this relation. We can easily identify if we have a direct variation if we are going to create a table representing the given. When we discuss the rate of change on the last unit, we said that our x always denotes time, days, minutes, hours. So in this case, 15 will be our x, and then the number of painters will be our y. So if we have 3 painters, it takes 15 hours. If we have 6 painters, we have 7.5 hours. We can check if we have a direct variation by using the formula y divided by x. If we have the same constant of variation, then this relation is a direct variation. So go ahead, let's try to divide 3 by 15. So 3 divided by 15 is equal to 0.2. So our k here is 0.2. Next, let's divide y by x, 6 divided by 7.5, and we have 0.8. Since we don't have the same k, this relation is not a direct variation. Direct variation given an equation. How do we know if an equation is a direct variation? Well, we said earlier that as long as you have y equals kx, then you will have a direct variation. So your goal here is to isolate your y. So how do we isolate our y? Divide or subtract 2x to both sides. We'll get 3y equals negative 2x. Divide both sides by 3, we'll have y equals negative 2/3 x. So let me rewrite this here. In this case, when we solve for y, it is of the form y equals kx. Therefore, a is a direct variation. Now, what if we have a point? Write an equation of the direct variation that includes the given point. Now, we know that the first number is x, the second number is y. We just need to complete this equation, y equals kx. We said that k in this topic is always y divided by x. So to find our k, or our slope, we just need to divide y by x. So y is 3 divided by x is 3 over 2. So we will have y equals 3 over 2x. Or you can also write this as y equals 1.5x. Alright, go ahead, pause the video and solve for letter B.
Math is a wonderful thing. Math is a really cool thing.